Algebra 2 spends a lot of time on quadratic functions, and there's going to be some times in calculus, and even in this course here, we're going to spend a good bit of time on or look at quadratic functions, or see if we have something that represents a quadratic, or could be represented by a quadratic function, because we have rules and procedures to handle those as well. I mean, linear functions and linear equations, I have procedures to solve and find information about them. Quadratic functions and quadratic equations, I have rules and procedures to find various things about quadratic functions, and I also have various things that I can do to solve quadratic equations. In order to graph a quadratic function, these are the things you normally have to do as part of the process. You want to find the vertex of the parabola. That's either going to be your maximum point or your minimum point. I mean, it's going to be one or the other. It's basically what they would sometimes call a turning point. It's either where the parabola is moving from increasing to decreasing, or from decreasing to increasing. We also want to locate the axis of symmetry. Well, the axis of symmetry is an imaginary line that cuts the graph in half. The vertex has to lie on that axis of symmetry. So basically, when we're dealing with functions, the x-coordinate of the parabola is also the number I would use in the equation x equals whatever that number is for the axis of symmetry. We want to determine whether there's a maximum or a minimum value. There's easy ways of determining that, before we even come up with a graph. And we also want to, at times, plot additional points to graph the function, because these things are parabolas. That's their shape. They're a parabola. Which means it's going to be a curve. Those curves could be like, very wide. They could be very narrow. So I want to know where certain aspects of them are and how the overall thing looks. So I'm going to need to have additional points. Whereas if I was just graphing a line, all I need to do is determine 2 points and I got it. That's it. Now we have various forms for the function notation for a quadratic function. The first type here is standard form, what a lot of books call it. Some other books call it vertex form. But it's basically f of x, or y, sometimes we'll put the y over there as well, equals a times x minus h quantity squared plus k. Your vertex would be at h comma k. Your axis of symmetry would be at x equals h. Notice again, I have a minus sign next to the h in parentheses, and I don't have it in the vertex format. So I do have some sort of change of sign here, kind of going with those graph transformation things we talked about earlier in chapter 1. If it's in that format, if a is greater than 0, meaning positive, then the parabola is going to open upward. It's going to have a minimum. If a is less than 0 or negative, the graph is going to open downward, and the vertex is going to be a maximum point. So I mean, if I just look at a very couple little things of this, I have already a couple major points of that I could focus my attention on that lets me know what that parabola looks like, and then with a couple more steps, I could actually get an accurate graph without a whole lot of effort on my part. So here we have this quadratic function in the vertex format or standard format. So if I want to draw a graph of this, first thing I'm going to find is, well, I know it opens downward, which means it's going to have a maximum, and I know where the vertex is because -2 tells me I have an x coordinate for the vertex at 2, and the -3 on the outside says I have a y coordinate of -3. So 2, -3 is it. I know it's going to open downward at some point, but I still need more points. I mean, I don't know how wide or narrow this graph is going to be. So what I do is I come up with, I start at 2, and I pick either some values that are bigger than it or smaller than it. I don't have to do both, because here's the reason. If I do, here I'm doing numbers that are bigger than it only. Okay, so what I'm going to be getting are things that are going to be the right-hand side of this parabola. So, if I put 2 into that function, I get -3, because that's my vertex. If I put 3 in, I get -5. If I put 4 in, I get -11. If I put 5 in, I get -21. Some of these don't really fall on the graph all that well. That 4, -11 kind of fell off a little bit, so I kind of guessed where it would be. But the thing I have to remember is, well, that number 2 is also where the axis of symmetry would be. The axis of symmetry is x equals 2. And an axis of symmetry means that if I have a point, on the right-hand side, its mirror image is going to be on the left-hand side. So when I look at the point, for instance, 3, -5, I need to have a mirror image of that point on the other side of that axis of symmetry, or 1 unit to the left. When I look at 4, -11, which is 2 units away from the axis of symmetry, I should have a mirror image of that point that's 2 units to the left of that axis of symmetry. So I can find two other points really easily. They're just mirror images. And that's enough to draw the parabola. And that's what it would look like.